Welcome to Study Labs. Today in Maths by Experiment, I'm going to demonstrate the use of a Theodolite and how you can use it in your maths classes and how you can give your students an activity based on simple mathematics. So this is the setup of Theodolite. Now you had seen a protector here, and I drilled a hole right here and hang a rope with I use a ball, but you can use a stone if you don't want to purchase a ball, right? You can always hang a stone with this. The only function of this ball is to keep it upright, right? And then I have a PVC pipe here, and the main motive of this setup is to make students aware about the errors that occur in the readings, right? So therefore I had used a bigger PVC pipe, but you can use a very smaller one and it will give you a more accurate result, right? So how we can use the theodolite, right? So first let's go to the theory section. So we are very familiar with the height and distance problem, where we have to find the height of a building or of a pole, and a man is standing say x distance away from the building or from the pole, and the man have to find the height of the building. So in those problems we can use our theodolite to measure the angle, right? So if we can measure the angle, we can find the height of the building. Suppose the height of the person is h, and therefore this must also be h. And if the total height is capital H, this is h minus h, right? Now this is x because the distance remains same, and therefore tan theta is equal to perpendicular upon base, and perpendicular here is h minus h upon x, or h minus h is equal to x tan theta. Now obviously the height or the total height will be this h minus h plus this h, right? So h minus h is equal to x tan theta, and this is our height. So we can say that capital H is equal to x tan theta plus h. Now we can find the height of the student, right? And I will point out the readings also from where you have to take care, right? But you can find h, you can find, or you can measure the x, and you can find the theta with the help of this theodolite, and therefore on putting in this equation you can roughly get the height of the building or of the pole, right? Now how to use it? What do you have to do? You suppose if it is in this position, in 90-degree position, the student will read the reading as 90 degree, but as it is shifted, right, it is pointing out at an angle, right? What will happen? The angle will change. The angle is changing. Now it is 50 degree, now it is 40 degree, now it is 30 degree, and obviously the person who has to take the readings have to make the ball stable, right? That's another thing, but those are the causes for error. But you can understand that if you are pointing something at this angle, right? Suppose the boy is standing here and the building is here, and then what you have to do? You have to point the center point of the theodolite onto this very point, right? So that he can measure the angle, and therefore at this angle it may goes like this, right? And therefore you have to measure the angle from here, from 0. So it is 54 or 53 something, and then you have to minus it from 90, and then you will get the value of theta, because when you are measuring with theodolite, what you are measuring? You are measuring this angle. This angle is theta 1. So by vertically opposite angle, this angle is theta 1. And if you have to find this angle, you have to subtract 90 minus theta 1 to get this angle, right? So that's the angle, how you can measure the angle with the help of theodolite. But again, as I said, I used this apparatus for giving the student an idea about the errors, that the original or the practical math is highly different from the math in the textbook. You can say that if you see the width of the thread, or the thread is itself covers 2 degrees in a single go, so there is an error of 1 degree angle, right? Then again, if you are measuring suppose the height of the student, you have to only measure it from the toe or the leg of the student up to its eyes only, not up to its head, because the theodolite is put here and not here on its head, right? And then the position always gives a error. You are measuring this with a measuring tape, so always there is an error possible there. And you have to point the tip of the building or the pole at the center point of this, and as you can see at the center point of this, it is hollow, and it has its own area something, right? So it's not easy to point the tip of the pole or the building exactly at the center, and it causes another source of error. So you can put a lens here or a mirror, and then you can draw two lines like this, so that students know exactly where they have to put it. And the ball is also again not very stable. You have to make it stable, right, like this, and then you have other person have to take the reading. So it is a two student activity, and it gives a very nice results up to a distance of say 3 meter. But after this, the change in the angle is not very much, and therefore it is also an important aspect for getting an error in the reading. So students get aware about the errors in their measurement, right? So that's all for this video. Meet you in the next. Thank you.